Good morning to one and all. My name is Tinaresh, and now I am saying the topic about the subject network analysis, and the topic is underdamped response of DC series RLC circuit. At first, we need to know what is nothing but underdamped response. An underdamped response is one that oscillates within a decaying envelope, and an undamped response is the response that does not oscillate above the steady state value but takes longer to reach steady state than the critically damped case. Here, damping ratio is greater than 1, and rather than that, we need to know what is an underdamped circuit. A highly damped circuit will fail to resonate at all when not driven. A circuit with a value of resistor that causes it to be just on edge of ringing is called critically damped. Either side of critically damped are described as underdamped, which is nothing but the ringing happens, and overdamped, which is nothing but the ringing suppressed. Next, how do you tell? If you tell that the system is underdamped or overamped, and that it was by when an underdamped system which moves slowly towards the equilibrium, an underdamped system moves quickly to equilibrium but will oscillate above the equilibrium point as it does. Here, to know the natural response of RLC circuit, we need to derive the natural response of a series resistor inductor capacitor circuit. The RLC is representative of real life circuits we actually build, since every real circuit has some finite resistance, inductance, and capacitance. Based on that, we need to derive the RLC circuit, which to know that whether it is underdamped system table, we will need to be somewhat oscillatory, but the amplitude of the oscillation decreases with time and the system is stable. And it is important to appreciate that the oscillatory does not necessarily imply instability. The rate of decay is determined by the damping factor, and which the damping ratio of that RLC circuit is nothing but damping factor and resonance frequency. Series RLC circuit type we need to categorize as like that. And to know that this RLC circuit work is when a resistor, inductor, capacitor are connected in series with the voltage supply. The circuit so formed is called the series RLC circuit, since all these components are connected in series. The current in which element remains the same. Let VR be the voltage across the resistor, or VL be the voltage across the inductor L, and else the bandwidth of this RLC circuit is in the system of the range frequency for which the current or output voltage is equals to 70% of its value at the resonant frequency, and it is denoted by BW. And to know the damping is best, it means the absorb up to 95% of shock energy and more than 50% of vibration energy of a million cycles we need to know. As therefore, to know how to solve a second order RLC circuit, based on that we can see many more videos in the YouTube.